Okay. Sunday guy, how's the audio, like the music? Is it too loud? I kind of just want it background. Okay, good. So I'm trying to decide, because I realized that there's like a prerequisite, because I was going to do guided pen test web, and there's prerequisites, and I don't know if I should just like go through the prerequisites first, just to brush up on those for anyone who might not be familiar with them, or just jump into the guided pen test. I don't know. You know, I think I'll just, I will go through the basics. So, for completion's sake, I want this to be like something someone can watch and go along with as they work through TryHackMe if they want to. So I'm gonna do that. So we're gonna do HTTP in detail, today. Should only take 30 minutes, but I'm reading aloud, so it might take a little longer. There's a video you can watch, which probably goes over what is in this, like what I'm doing, so I'm not gonna watch it. Just gonna go through the tasks. So, what is HTTP? It stands for Hypertext Transfer Protocol. So HTTP is what's used whenever you view a website developed by Tim Berners-Lee and his team between 1989 to 1991. HTTP is the set of rules used for communicating with web servers for the transmitting of web page data, whether that is HTML, images, videos, etc. So what is HTTPS? You're probably most familiar with that one now. Most websites don't use HTTP anymore. And if you are on an HTTP one, it's probably not a good thing, unless you like know what you're doing. So always kind of keep your eye out on that. Don't enter any information unless you know the source of what you're doing. HTTPS is the secure version of HTTP. HTTPS data is encrypted, so it not only stops people from seeing the data you are receiving and sending, but it also gives you assurance that you're talking to the correct web server and not something impersonating it. All right. Oh, I forgot to join the room. Got to join the room so we can... What error? Let me refresh. Join room. There we go. Okay, now we can add it. So it stands for Hypertext Transfer Protocol. Sweet. And what does the S stand for? Secure. Okay. And we need to view the website. So, what is wrong with the website? Well, as you can see, as I was talking about, there is no S there. It's not secure. So, I guess it wants us to click on it to get the flag. Yeah. So we got the flag. Copy that. Invalid HTTP cert. All right, task 2. What's this? Split view. Okay. So requests and responses. When we access a website, your browser will need to make requests to a web server for assets such as HTML, images, and download the responses. Before that, you need to tell the browser specifically how and where to access these resources. This is where URLs will help. So what is a URL? It stands for Uniform Resource Locator. If you use the internet, you've used a URL before. A URL is predominantly an instruction on how to access a resource on the internet. The image below shows what a URL looks like with all of its features. It does not use all features in every request, though. So we've got the scheme, which is HTTP. So this instructs on what protocol to use for accessing the resource, such as HTTP, HTTPS, and FTP, File Transfer Protocol. And then next we have the user, the password. So some services require authentication to log in. You can put a username and password into the URL to log in. So I've never really used that much. You don't see it too often, but yeah. Then we have the host/domain. So the domain name or IP address of the server you wish to access. Then we have the port here. So the port that you're going to connect to, which is usually 80 for HTTP and 443 for HTTPS. But this can be hosted on any port between 1 to 65,535. So those are all the different ports you can have. And then you have the path, which is the file name or location of the resource you are trying to access. That would be the view room. Right there is the path. Then you have a query string, which is extra bits of information that can be sent to the requested path. For example, blog !ID = 1 would tell the blog path that you wish to receive the blog article with the ID of 1. So that's what it is there. There are other queries that you can do. It's always followed by the question mark there. That's kind of like how you know that it is a query string. And then we have a fragment, and this is a reference to a location on the actual page requested. So this is commonly used for pages with long content and can have a certain part of the page directly linked to it, so it is viewable to the user as soon as they access the page. So this would, I use this a lot when I do development. If I want to like have like a menu of links that you click on and it scrolls to the section that you put the ID of the fragment there. So making a request. It's possible to make a request to a web server with just one line, get/http/1.1. So you can just send a get request, which means, hey, give me that page. But for a much richer web experience, you'll need to send other data as well. This other data is sent in what is called headers, where headers contain extra information to give the web server you're communicating with. But we'll go more into this in the header task. So this is an example request right there. These are the headers. That's what it's talking about here. So line 1 is the request sending the get method. And this is going to be, I guess, covered more in the HTTP methods task. Requesting the home page with / and telling the web server we are using HTTP protocol version 1.1. Okay, so the host is telling the web server we want the website TryHackMe.com. The user agent line is we are telling the web server we are using the Firefox version 87 browser. So this is like one that you might need. It's like important to like know if you like want to like, for example, if you have like a website where they're like, oh, this browser doesn't work with, or this website doesn't work with your browser and you don't want to switch to that other browser, you can spoof your browser and change the user agent that's sent over to the server. So that's like one example of what you can do with the user agent header. And then line 4 is the refer. Notice how it's misspelled. We are telling the web server that the web page that referred us to this one is https tryhackme.com. So there's actually a funny story about why it's misspelled. So when they were building it, they misspelled it, and they didn't realize that till it was a little too late. And so it's kind of like a joke that they're just like, we can't spell. So yeah, I just always laugh when I see it, because people are always on your case about spelling and stuff. You know, it's important, and something that everyone like uses on the internet, it's misspelled. They just left it. So it's just my English nerd in me laughing at that. So then there's a line 5. HTTP requests always end with a blank line to inform the web server that the request has finished. So here's an example of what happens when you send the request and you get a response. So to break down each line of the response, so line 1 right here is the version of the HTTP protocol the server is using, and then followed by the HTTP status code, in this case 200 OK, which tells us the request has completed successfully. So line 2 tells us the web server software and version number. And then line 3 is the current date, time and time zone of the web server. And then we have the content type header, which tells the client, which is you, sending to the web, requesting the website. So it tells the client what sort of information is going to be sent, such as HTML, images, videos, PDF, or XML, or many of the other different kinds of information. Content length tells the client how long the response is. This way we can confirm no data is missing. And then we actually have the HTTP response, which contains the blank line to confirm the ending of the HTTP response. There's that. And then you have the information that is requested, which is the instance of the home page. So this is just the HTML of what you would see behind the web page that's being sent. So what HTTP protocol is being used in the above example? So we got HTTP 1.1. And then what response header tells the browser how much data to expect? So that's the content length header. Content length. There we go. Okay, next section is the HTTP methods. So one you might be we were talking about is the GET request. So we'll go into detail of that more, but HTTP methods are a way for the client to show their intended action when making an HTTP request. There are a lot of HTTP methods, but we'll cover the most common ones, although you'll mostly deal with the GET and POST method. So get request is used for getting information from a web server. Post request is used for submitting data to the web server and potentially creating new records. The put request is used for submitting data to a web server to update information. And the delete request, which is used for deleting information / records from a web server. That one's fairly easy, but what method would be used to create a new user account? It would be the post. Post. Because you are submitting new data and creating a new record. So what method would be used to update your email address? Well, it would be the put method because you are updating information. So you're sending data to update the information on the server. Okay, so what method would be used to remove a picture you've uploaded to the account? That would be the delete. I think that's very self-explanatory. And then what method would be used to view a news article? That would be the get. All right, HTTP status codes. So in the previous task, you learned what HTTP server responds. The first line always contains a status code informing the client of the outcome of their request and also potentially how to handle it. These status codes can be broken down into 5 different ranges. So 100 to 199 is information response. So these are sent to tell the client the first part of their request has been accepted and they should continue sending the rest of their request. So these requests are no longer very common. Like I've never seen it. So yeah, it's not very common. And then 200 to 299 is success. This range of status codes is used to tell the client their request was successful. So that's an example of the other one that we looked at. The response was the 200, the OK, 200 OK. Then we got 300 to 399 redirection. So these are used to redirect the client's request to another resource. This can be either to a different web page or a different website altogether. And then 400 to 499 is client errors, which is used to inform the client that there was an error with their request. And then 500 to 599 is server errors. This is reserved for errors happening on the server side, which usually indicates quite a major problem with the server handling their request. So these are the common HTTP status codes. There are a lot of different ones, and that's not including the fact that applications can even define their own. But we're going to go over the ones that we are most likely to come across. So we already went over the 200 OK, which is the request was completed successfully. Hold on, I need some water. Okay. 201 is created, so that means a resource has been created, such as a news user or a blog post. 301 is moved permanently, and this redirects the client's browser to a new web page or tells search engines that the page has moved elsewhere and to look there instead. 302 found is similar to the above permanent redirect, but as the name suggests, this is only a temporary change and may change again in the near future. So 400 bad requests. This tells the browser that something was either wrong or missing in their request. This could be sometimes used if the web server resource that is being requested expected a certain parameter that the client didn't send. 401 not authorized is you are not currently allowed to view this resource until you have authorized with the web application, which is most commonly with a username and password. 403 forbidden is you do not have permission to view this resource whether you are logged in or not. 405 method not allowed is the resource does not allow this method request. For example, you send a GET request to a resource /create account when it was expecting a POST request instead. And then 404, page not found. I think that's probably one that you might be familiar with. I mean, there's a lot of jokes and stuff about it. But it just says that the page/resource you requested does not exist. And then 500, internal service error is that the server has encountered some kind of error with your request and that it doesn't know how to handle properly. And then 503, service unavailable is that the server cannot handle your request as it's either overloaded or down for maintenance. Oh, that's cool. There's a resource at http.cat to study the status codes. Click the view site button on the right. See what the... Oh yeah, HTTP cats. I've seen these before. Partial It's cute. This is too cute. Method not allowed. Don't eat the cat. Length required. Oh no, precondition failed. Washing the cat. Oh no, expectation failed. Oh yeah, there's a 418, which is I'm a teapot. That's like a real thing. I'm a teapot. Answer your call. Is that... Did you... Is that real? Oh, okay. Method failure. That's so funny. It's an unofficial one. Okay. I was like, for real. This is really funny. Too early. That's how I feel all the time. These are really funny. The internal server error. There's a cat in the server. These are cute. Anyway, if you want to know what the specific ones are and read about it, I guess it has like descriptions and stuff with the pictures and tells you a little more about it and has extra sources. So that's cool. http.cat. That's the site. Okay, so what response might you receive if you've created a new user or blog post article? So that would be 201. Okay, what response code might you receive if you tried to access a page that doesn't exist? That'd be 404. And what response code might you receive if the web server cannot access its database and the application crashes? That would be 500? Oh, I guess not. It might be 503. Yeah, okay. Oh, duh. Service is unavailable. Okay. What response code might you receive if you try to edit your profile without logging in first? That would be not authorized, right? 401. Okay, awesome. Now we've got the headers. Headers are additional bits of data you can send to the web server when making requests. Although no headers are strictly required when making an HTTP request, you'll find it difficult to view a website properly. So common request headers are these ones that are sent from the client. Ooh, my stomach was growling. I'm hungry. So usually your browser to the server. Host. Some web servers host multiple websites. So by providing the host headers, you can tell which one you require. Otherwise, you'll just receive the default website for the server. User agent. This is the browser software and version number that you're using. Telling the web server your browser software helps it format the website properly for your browser. And also some elements of HTML, JavaScript, and CSS are only available in certain browsers. Content length. When sending data to a web server, such as in a form, the content length tells the web server how much data to expect in the web request. This way, the server can ensure it isn't missing any data. Accept encoding. Tells the web server what types of compression methods the browser supports so the data can be made smaller for transmitting over the internet. And then cookie, which is data sent to the server to help remember your information. So that's probably the one that most people are familiar with, is the cookie header, because of the whole, do you accept the cookies or whatever pop-up that I'm like, yeah, letting you know that the site uses cookies and you have to like accept that. Which is like kind of dumb in a way, but people kind of misunderstood what cookies actually were back when they passed that law. Anyway, so common response headers. These are the headers that are returned to the client from the server after request. So set cookie, information to store, which gets sent back to the web server on each request. So then we got cache control, how to store the content of the response in the browser's cache before it requests again. Content type, this tells the client what type of data is being returned, like HTML, CSS, JavaScript, images, PDF, video, etc. Using the content type header, the browser then knows how to process the data. And then content encoding, what method has been used to compress the data to make it smaller when sending it over the internet. Okay, so what header tells the web server what browser is being used? So that would be the user agent. Okay, what header tells the browser what type of data is being returned? That would be content type. Okay, and what header tells the web server which website is being requested? Host. That. Awesome. And we got cookies. So you've probably heard of cookies before. They're just a small piece of data that is stored on your computer. Cookies are saved when you receive a set cookie header for, web server. Then every request you make, you'll send the cookie data back to the web server. Because HTTP is stateless, meaning it doesn't keep track of your previous requests, cookies can be used to remind the web server who you are, some personal settings for the website, or whether you've been to a website before. Let's take a look at this as an example of an HTTP request. So right here, this client requests the web page from cookies.thm, and then the server responds back with a simple web page with a form asking for the user's name. So the client sends back the form with the name and sets it to Adam. So equals Adam. And then the server responds with a set cookie header telling the client to save the data name equals Adam. So it's setting the cookie there. And then on the next request, and every other further request that the client sends to the server, it sends the cookie data along with it. Right there. And then the server then sees the cookie, and instead of displaying the form, it displays a welcome back message instead. So like when you log into an application and you hit, you know, stay logged in, it stores it as like a cookie. So when you come back, it knows that you're the one that's logged in. And that's why when you say like clear my cookies in the browser, you get logged out of all your websites. So cookies can be used for many purposes, but are most commonly used for website authentication. The cookie value won't usually be a clear text string where you can see the password, but a token, which is a unique secret code that isn't easily humanly guessable. So viewing cookies, you can easily view what cookies your browser is sending to a website by using the developer tools in your browser. So let's see. It would be tools, web developer tools. So it opens up the developer tools. And then if you click on the network tab, and I guess we have to hit reload. So here's all the GET requests, the GET methods. So so these are the different requests and responses. So when we let's go up here. Ugh. Anyway, it'll just show like a cookie there, whatever. Yeah, see, here's a cookie. Literally long thing is a cookie. So what header is used to save cookies to your computer? That would be set cookie. Sunday guy, I want cookies. All right, last one. We're gonna click view site right here, and we're going to... Wait, what? Show more of the window? Oh. Well, I already closed it. Anyway, it's not that important. Let's see, would you like to take a guided tour on how to get started? Sure. Oh, it was? Huh, strange. Oh! My whole site is just cut off. Why did I not? I forgot that I did that. Let's see. What is the button? Okay, it's locked. Ugh. Let's see. Might have to, or window. Oh, no, that's audio capture. Window capture. Let me fix this. Ah! I have to add entirely new source because I cannot figure out how I cropped it. Window capture. Connect. This one. Okay. And then... Ugh, my stomach. Let me fix it. Fit to screen. Wow. That's better. Now you can actually see my whole screen. Let me get rid of the other one. No, don't remove name. Okay, I will do that. That there. Yes. Let's see. Settings. Display. Desktop. No, it's not desktop. Type. Here it is, display. Up the scale, maybe. Odd. Well, I'm so close to being done. Let me look. Okay, let me give this a try. Oh. That's way too big. No. No. Yes. Let's try this other way. Let's see, settings, appearance. Settings, window scaling. Can't I do it like in a half? Well, I guess this'll do for now. I'll figure it out later, but at least this you can actually see. Okay, so we got the method. You could change your URL, then send request, parameters. All right. Maybe. I will try that then. Fixed. We are learning this as we go. That's true. Is that good? Should I go any bigger? Breaks this if I go bigger. Okay, we're gonna make a get response to the /room page. Oh, 150? Okay, I'll go 150. All right, so go. We got the flag here. You're in the room. All right, so now we're gonna do a get request from the blog. The blog page. And we're gonna set the parameters. We're gonna have the key be ID and the value to 1. Hit go. This is the request. And the body here, it says you found the blog. All right, now we're gonna make a delete request. We're gonna delete a user. The user /1 page. Oh, wait. So, see, it says that the user has been deleted. Oh, can I finish this before? I got the race to get it before the ad. Okay, we're gonna do a put request. And we're gonna do user 2 with, it was the parameters. Oh, okay, we can do multiple. Okay, we're gonna get the username parameter set to admin. That didn't work. Oh, because I did 12. All right, so it says the user has been updated to admin. All right, so then we're gonna do the login page. And we're gonna do the password, let me in. And we're doing a post request. Missing post, did it change on me? Yeah, it changed. Yeah, okay. Bad request. Oh, I forgot the the username. I skipped that. Name. THM. Password. Let me in. Okay, there we go. Request master. And we've got it. Maybe? Okay, we finished the room. Huzzah! Alright. Got the badge webbed. Ah! No touchy the axolotl. So now we understand how HTTP works. The headers and stuff. And that's all for today. I'm gonna head out before ads. Oh, we're in ads now. I guess I'll wait for ads to be done. As we continue going on, I think we'll do the other prerequisite web application basics. I wish I could do this one, the Linux CLI basics, but it's a premium room. Alas. I don't think I can stream premium rooms anyway. I think I can only do the free rooms, so I bet I could find a different site that has like CLI basics, but I'll have to look into that. But we'll do the web application basics next. And then we can jump into the guided pen test. So we didn't really do any hacking today, but we learned stuff that you do need for web hacking. And that's, like, really crucial to know. Because, like, you're going to be modifying parameters a lot. You're going to be modifying the cookies. So you're gonna definitely be changing the headers and messing with the cookies. So it's good to know what those things are. But yes. And I don't know. What's this? Oh, I'm level 3. Topic rewind recap. What's that? Recaps. Reinforce what you learn. I don't recall even doing any of this. So let's just ignore that. Anyway, ads should be done in like 30 seconds, and then I'll do my little close off spiel. I haven't like delved too much in this website, but it seems pretty good for like starting learning the basics. There's also Hack the Box, but I think that's a little more advanced from what I've like looked at. So I would recommend that newbies start with TryHackMe first. But welcome back, those who were in ads, which I don't think there was any. Maybe. Anyway, yeah, I'm gonna head out. I'll be back on Saturday. I have to take tomorrow off because I'm doing a cybersecurity training from SANS. It's a free summit, so if you're like interested in that, let me see which one it is. The SANS summits. Their live training the summits here. So all of these, if they're online format, live online. Anyway, so it's going to be the Sand Security Awareness and Culture Summit tomorrow. Online. And Friday. So that's why I'm not streaming, is because it's going to be like a good chunk of my day, and I don't think I'll have the energy to stream. But I will be on Saturday. I'm going to try to play Animal Crossing, but I need to figure out why it's not loading. Because, like, it was running fine when I first installed it, but now it's not loading, and I have no clue why. So I'll troubleshoot that, and if I can't figure it out, then I'll probably play Fields of Mysteria again. But I'm just looking at what other summits, because I have to attend these summits to get my CPEs, which is the credits of continuing education, so that I can keep my certifications active. So it looks like I could do the AI Cybersecurity Summit to get, because I have like a few CPEs for my web application penetration testing certification that I need to renew. And hopefully I can get them all done in time. Anyway, as I was saying, Saturday, if I don't get Animal Crossing working, I'll probably play Fields of Mysteria. But I was also thinking of possibly doing Tomodachi Life again, because we haven't seen them for a couple of weeks, and I thought it might be fun to make more characters like Alois. Maybe no, I already made Shamir and Catherine. So it'd be like Alois. Who else? Made Gilbert. I guess I could make Rhea. And then maybe I could make like Sothis and Arval, possibly. I mean, I'm not going to be making them all, but I just like in the future who I want to make. I kind of think about making Fabio. He's 2 meters tall. He's a tall guy. That's like, what, 6'7"? 6'7". Sorry. 6'7" is 2 meters. Is that right? I didn't do that on purpose. Anyway, I think it's time for me to go. I'm getting hungry. So, what is it then? 2 meters in feet. Meters to feet. Oh, it's just under 6'7". It's 6.5 feet. So 2 inches off. Well, 1.5 inches off. But he's not 6'7". I think the thing that I was looking at was 200 centimeters, right? I don't know why I thought it was 6'7". I don't know. I thought I looked it up and it said that, but apparently not. Anyway, he's still tall. Maybe. God, it's not even Zoomer culture. It's like Gen Alpha's humor. Gen Alpha brain rot. All right. Anyway, I'm gonna head out. See y'all on Saturday, 6 p.m. Pacific. And have a good one. See y'all later. Bye. I kind of want to raid Dizzy. I'm going to raid Dizzy just as a joke. So stay around, Sunday guy. I'm going to raid him. Let's see. Raid channel. Following Dizzy. Start raid. I'm unable to raid Dizzy. Ugh, okay, never mind. I'm not raiding him. Have a good one. See y'all later. Bye.